Let's go through LeetCode 1937. Maximum number of points with costs. For this question, it gives us a two-dimensional m multiplied by n board, and we call it points. And for every cell, for example, row I, column J, the point ij will be those kind of points we can retrieve if we select this kind of cell. And it asks us to select one cell in each row and add those kind of points up to get the maximal point, right? So we know if we there is one constraint is that if for example we we select I minus 1 J1 row, right? This kind of cell. If we in the next row we select I J2, right? So instead of add these 2 points, we should also subtract those kind of diff, that is absolute value J1 minus J2. Okay, so that is the column differences. So ask what's the maximum points we can get. Let's take a look at the example 1, right? So you say the maximum result is 3 plus 5 plus 3, but 3 plus 5, the column difference is 1, so we should minus 1, right? And also plus 3, the column difference, these two, they have 1 difference, so the total, the maximum will be 9. We'll see that those numbers will always greater or equal to 0, and m multiplied by n is 10 to the power 5, right? So we are thinking about whether we can do this question in m multiplied by n time complexity, right? So what we think about is that we should do this kind of question is that this is pretty much like dimensional dp, right? So for every dp ij, that will be if we collect these points ij, right, at a row I column j, what's the maximal point we collect so far, right? So in the end, what we need is to compare the last row, right? So the dp n minus 1, right? And j is from 0 to m minus 1, right? Find the largest value for the last row. So the problem for this is that for every dpij, right, and we need to compare every dpi minus 1 and j from 0 to m minus 1, right, to find the largest one of this and plus current point ij. So if in that case we have m row and there are n columns, right? And for each column we need to iterate n previous n cells, right? So that will be m multiplied by n squared times complexity. That will apparently not efficient. So what we're thinking about is we should do something more efficient, right? We'll see when we observe this kind of question, we'll find that actually there are a lot of things we calculate multiple times, right? For example, for every dpij, we want to find for the previous dpi minus 1 j from 0 to for example j minus 1, right? We already calculate this part. And if we iterate dp ij plus 1, right? And if we consider 2 directions to separate these two from left to right, this one, if we have found the largest one, right, we should not iterate this again, right? We just add one more element to contribute from the left to right, right? So on the other hand, if we iterate from the right to left, right? So there is dpij. Well, if we already have dpi plus 1j, right? That means we also calculate on the right part. So we separate this question into two directions. One is from left to right, another is from right to left, right? So if we can separate this kind of question into two directions, then our dpij will be max of dp from the left, and also the max from the right, right? So separate, because if we separate that into two directions, right, that we can get our things simpler. And what we are going to do is that for every dp, if we iterate from the left to right, we are going to use something called left max to represent what is the dpi minus 1j, right, to j so far. And if we have j, right, add one more, we just compare this one to a new dpi minus 1j, right? So that if we go to the next one, for the left max, we just need to compare the previous left max and then the new dpi I minus 1j plus 1, right? So that if we keep this kind of variables on the left, then our dpij on the left position, we have a result. We can do the similar, that we use a variable called the right max, right? Right max. And we know this left max, the right max, we can set as 0 at the beginning, right? But the right max, we are iterating from m minus 1 to 0, right? So we calculate in another direction, that is dpij, another dpij, right? So we get for every dpij, we use a minimum for this, right? So doing like this, we use some kind of left max or right max variable. We can carry over the from 0 to j calculations to j plus 1, right? And also we calculate from n minus 1 to j, right, to n minus 1, j minus 1, right? So that every row it will just calculate n times. So the time complexity will be just O(m) multiplied by n. So after this analysis, we just write code. We are going to have int m equals points dot length, right? And n equals points 0 dot length. And we are going to have long dp, okay? dp equals new long m multiplied by n. So we know dpij means dpij means at a row I j column, what's the maximal points we get so far, right? And initially for the first row, for the first row, we can set the initial value. It will be the points first row, right? So dp, let's do int column equals 0, column smaller than n, column plus plus. So we are going to have dp first row column, right? Should be points 0. And then we are going to iterate the rows, right? For int row equals 1, row smaller than m, row plus plus, right? So we are going to use a variable called for the left max, right? We know this kind of value because every cell they will be greater than equal to 0. So left max, we can set a initial value as 0L first, right? So what we do is for int colon equals to 0 colon smaller than n colon plus plus. Then we are going to have left max equals max dot max left max. Should -1, right? Because if we go to from I to the column J to J plus 1, right? That means the maximum here, right? We have 1. We should have the difference, at least another difference here, right? So we should have left max -1 here, and also we have a new variable that is dp row -1 column, right? So we'll say every dp row column should be left max plus. This is from the left to right direction. Point row column. Okay. So we are going to, this is from the left to right. Then we are going to have a right max is from the right to left. So we are going to for int column equals a -1 column greater equal to 0 column minus right. So what we do is that right max equals max dot max right max -1, right? Every time we move one column, the column difference we should have this value -1, and we'll have dp the previous row, right? Wrong in the column. So for dp row column, what we are going to do is should max dot max, right? We should have two directions because for we may keep from the left to right one, right? Or we are keeping the right max plus these kind of points. And also for the last column, last row, we need to find the max. So long result equals 0L for column int column equals to 0, column smaller than n, column plus plus. And the result should be max dot max result dp and m -1 column, right? And in the end we return result. Doing like the time complexity will be m multiplied by n. Let's write a Python version for this. We are going to have m n equals length points and length points 0. And we need to have a dp equals this one multiplied by n for in range m, right? And we are going to have dp 0 equals 0.0, right? 0.0. And for row in range from 1 to m, we're going to have L max equals 0. And for column in range, and we're going to have L max equals max L max minus 1 and dp row minus 1 column. So from the left to right, we have dp row column should be left max plus this kind of points, points row column. And we also need another direction is right max, right? So we have several questions which there are two directions, but we need to separate that into for example just forward and backwards, right? And there are sometimes find there is a question find the closest zero matrix, right? We find the doing dp from left upper first and then do right below first in another round, right? So this kind of technique can get our problem into one direction. So we also have column in range n minus 1 minus 1 minus 1, right? So what we do is that right max equals max right max minus 1 dp row minus 1 column. And we should have dp row column, right? We should have max dp row column because we need to have the both direction value, right? And also the right max plus points row column. And in the end, we just compare the last one. So result equals to 0. And for column in range 0, in range n, right? We're going to have result equals max result dp minus 1 column. And the return result